2.3 is all about getting information from the graph of the function. So by the end of today, you're going to be able to analyze functions by discussing and finding maxima and minima and changes in direction on the graph. And then you're going to use functions to model optimization, which are finding the maximum min in certain problems. Do you guys remember how to find the maximum and the minimum on a graph? On a graphing calculator? Hey, we are going to go over that today, but it may seem familiar to you because you have done it before, and that's perfectly fine. I have to apologize because on your copy, I know this photocopy did not turn out so well, and this is really dark and kind of hard to read. I'm gonna show you mine from the textbook. Okay, but I did want to print it on there so you guys could see what it is. Will you go ahead and read through example 1 and then part A, and if you think you know how to do part of part A, then go ahead and give it a try. Okay, so Colin, what is this graph showing us here?
Battery being charged.
Yeah, okay, so the percent charge of your battery, and the numbers at the bottom represent what?
Time of day.
Yeah, the time of day, right, from 0 to 24 hours. Okay, and like I said, I do want to show you a clearer version of this graph to help us along here. All right, so for part A, it says we have to find P of 0, P of 9, P of 12, P of 17. The height of the graph is going to be the value of the function. Okay, so the height of the graph is the value of the function. And what that means is, if you're trying to find P of 0, you just have to look at the height of the graph when x is 0. Okay, and 0 is probably going to be one of the easier ones to find on your hard to read graph. Dylan, at 0, it looks like we're where?
80.
At 80. So see how at 0, if you go straight up, you can see that we're 80 right here? Gosh, that looks awful. It is just show you on here. So 0, we're at 80, so you guys can see that. Okay, so then we're just going to write P of 0 equals 80. Then we're going to do the same thing for P of 9, P of 12, and P of 17. Okay, and we're going to kind of estimate these together because, like I said, I know yours is a little bit harder to read. Okay, so to do this, I usually use a ruler. I'm not going to write in my book because that is a big no-no. And so what I'm going to do is I'm going to go to 9 on the x. Okay, and when I go to 9 on my x, I'm going to look at the corresponding y value. Okay, so this is right between them. It looks like, if I get my ruler straight, I'm about right here. and then I would go ahead and I would follow that straight across. And it looks like I'm about halfway between 90 and 100, which means I would estimate that to be somewhere around 95. Okay, so if I was doing it on this graph, what I would do is I would draw just like a dashed line. So I'm just going to show you that. So at 9, okay, and then once I have where it is on the X, I would just follow it over and see where it hits on my Y. Okay, so even on here, with the one that I drew, it could be about 96, about 97, and that would be fine. Okay, you can clearly see it is above 95 and below 100, so you should have somewhere between 95 and 100. Okay, so when you're doing this on your homework, if you're somewhere close within the approximation range, that's perfectly fine. On your quiz, it'll be multiple choice. Okay, so you'll be able to detect which one is the correct one and which ones are off base. Okay, so same thing for 12. So if we look at 12, if we follow that straight up, looks like it hits about here. So I'm going to follow that over. And I'll give you guys a chance to do that as well. Right, so looking at yours, if you go up from 12, what are you guys approximating for 12 on yours? About 74? And that's a little bit higher. About 75-ish? Okay, so somewhere in the 75 range. And then the last one would be P of 17. So 17 is going to be halfway between 16 and 18. Oops. Okay, and then we're going to go over. Okay, and here was my mark, so it looks like that is about at where? You just get around 85. Okay, and again, as long as it's somewhere around 85, that is perfectly fine. Okay, so then for part B, it's asking you which is larger, P of 14 or P of 18. So if you look at where P of 14 is, okay, P of 14 is going to be somewhere around here. P of 18 is going to be somewhere around here. Which one has the greater height, P of 14 or P of 18?
18.
P of 18. So P of 18 is going to be larger. And then the next thing we have to do is find the values of x for which P of x is less than or equal to 70. Do you guys have any ideas on how we could do that? Yeah, Logan?
Where it's, like draw a line where that's 70.
Okay, yeah, so that's exactly what I'm going to do. So I'm going to draw a line at 70, which is right here. and then I have to find the x values that coordinate to where it is at or below 70. Okay, so I would say it starts about here and then goes here. And again, I would just want to follow that down and estimate where that's going to be. So if I follow this part down, it looks to be at what number on my x?
13.
Looks to be about 13. Good. This one looks to be about what? It looks a little bit past the 16. So I think I would estimate that to be 17.
No, we agreed 17 was 85.
What's that?
Yeah, we agreed the P of 17 was 85.
Your blue line's a little off the,
Yeah, you're
if you shift your
Oh,
line a little
okay,
bit to the
yeah,
right.
because you're saying, yeah, your P of 17 is about at 85. And then, okay, so let's start with your 13. But it clearly looks like it's above that, doesn't it? Does your guys look
think
like
you're-
it's right on 13 or a little bit above?
I have right on 13.
Okay, so if it's right on there, I would put the greater than equal to. Yeah, I know, it's really weird.
I think that line needs to be shifted to the right a little bit, and
That,
then you'd be on 16.
but not exactly. Let's do 16. Because wouldn't 16 be more like right here? So could we agree it would be somewhere maybe between 16 and 17? Okay, so then
Slightly off the 16.
instead of putting including 17, what if we did this? I know, you didn't nod. Okay, so if it's, can we agree that it's somewhere less than 17, but then maybe equal to 13? Okay, so if it's not right on it, you don't have to include it. It can just be less than or greater than. Okay, if it is going to be right on it, then you can include your equal to. And so that will vary depending on the situation. And again, I know your photocopy did not turn out so well. All right, so now we're going to do the domain and the range. So the domain is the set of what? X values. So the domain corresponds to the X values. The range corresponds to the Y values. So for this, we can say X such that, and what is our lowest X value? It's 0. And the highest X value? 24. Okay, because remember your X values are representing the hours. Now if you wanted to write that as an interval, you could do 0 to 24. Okay, now your range, you're going to have to find your lowest Y value. Okay, so find the lowest part of that graph. Okay, and your lowest part of the graph, I'd say is about here. So does it look like it's a little bit more than 50? 55-ish? I said 52 the first time. I think it looks more like 53 or 54. As long as you're somewhere in the ballpark, you're going to be fine. So we're going to use 52. And then what is your highest value? 100. Yep. Okay, so you can see when you are using the graph, there are gonna be some points that are just gonna be approximations. Okay, so what you have might not be the same thing as the person next to you has, but you could both be correct. Okay, for many of those, they are gonna be approximations. And when you're using your graph, that's gonna happen. But for ones like example 2, now we're gonna get into different functions, and we're going to, first we're gonna find the domain and range, and then later we're gonna learn how to find your maxima and your minima. Okay, so let's get out our graphing calculators if we don't already have them. And I learned a cool new trick today. Jeez. So I will share it with you. Okay, so one way that you could put this in your calculator is you could do 1 divided by 1 plus x squared.
Can't see the screen. It's too dark.
Thanks. Get into the light. Okay, so is that how you would usually put that in there?
No.
No? You know another way? Did your calculator do that, or do you know how to do that?
No, I know how to do it.
Oh, okay. Do you want to tell us?
No, go ahead.
Okay, so if you go to alpha, if you press alpha, and then y equals, see how the first thing says n over d? Numerator over denominator?
The newer calculators,
Yeah?
you hit math,
Yeah?
slide over to the fraction,
And then it'll put it in there?
it's the same thing.
Oh, cool. So then look, 1 over 1 plus x squared, and then you don't have to worry about those pesky parentheses that can trip us up sometimes. Isn't that cool?
Yes.
Doesn't seem like you guys share my enthusiasm. Okay, so now we're gonna go ahead and graph. Now if you just want to graph on a 10 by 10, if you go to zoom and then 6, which is Z standard, that is going to give you the graph on a normal 10 by 10. You can see it looks like we have a very small little hill there. So yesterday we talked about how you can adjust your graphing window. That's what we're going to do today. And I think what I'm going to do is go from -5 to 5. That's actually the graph I gave you is -5 to 5 and -5 to 5. And then for your min and max, I think I went from 3 to 3, just so I could see a little bit clearly. Now, when you're sketching the graph, I do want you to have a couple of valid points in there. What can you guys use to get some valid points?
The table.
The table, that's what I would do. I think that's the easiest way, right? So I could go to second table, and then at 0, it says I'm at 1. And look, see with my fraction? Look, it gave me all those as fractions. Isn't that cool? Wow. Okay, and then at 1, I'm at a half. And then at 0.5, I'm at a half. And then I'm going to go ahead and connect these with a curve. What do you guys think? What do you guys think is the lowest y value? Yeah, just above 0. Why don't you think it is 0? Okay, yeah. So if we kept going on our graph, do you guys know how to change your table to where it starts? If you go to second table set, it says table start. Let's say I wanted to see what happened when x is 500. At 500, am I at 0 yet? No. So I am getting really, really close to it, but it's not going to touch 0. So that's going to affect one of the things we are trying to find. So first let's talk about domain. Okay, so domain is going to be the set of x values. So x such that. Now let's look at the x here. So I have this little arrow. So Nick S, I would say that on the x, this is going out to what? Positive infinity. On the other side, it's going to negative infinity, and so the domain would be All real numbers. So the way that we're going to write that in set notation is x such that x is an element of the set of real numbers, or in interval notation, negative infinity to infinity. And then your range is your set of y values. So we have to find the lowest y value. We just talked about how does y reach 0? Nope, it just gets very, very close to it. So then what we would say is 0 is less than y. And then what's the highest y value? It's 1, and it actually reaches 1, so that's why we have to include it. And if we wrote that as an interval notation, we would have a soft bracket on 0 to show it does not include 0, and a hard bracket on 1 to show that it does include 1. Okay, so we sketched the graph, we found the domain and range. That's all example 2 was asking us to do. So we can go ahead and move on to example 3 and our next topic. So the next thing we're going to talk about today is increasing and decreasing intervals. So you can see here from A to B, the graph is going up, correct? You can see this is going up from A to B. We would say that the interval it increases on is, this is your x value, little a to little b. Okay, so this is the increasing interval. The other interval where it's increasing is from point C to point D, which you can go ahead and look at the corresponding x values on that. So this is another increasing interval. The one in the middle is going down from left to right. So that is our decreasing interval. And that would be from B to C. Okay, so whenever you are trying to find the interval on which a graph is increasing or decreasing, you are going to use the x values. Okay, in order to find the interval on which a graph is increasing or decreasing, you will use the, and really I should have said corresponding x values. Okay, so in order to find the interval in which a graph is increasing or decreasing, you will use the corresponding x values. So for example 3, when we're told to graph the function, and we're going to do that using a graphing device to draw the graph of f, we're going to sketch that below. And then for part B, we're going to state approximately the intervals on which f is increasing or decreasing. So your intervals are going to be the x values. Your max or your min is what value? The max or the min itself is the y values. The intervals on which it's increasing or decreasing is going to be the x value. So let's go ahead and graph this. Okay, so I have x cubed minus 4x. And because this is a 5 by 5 window, I think I'm going to make this a 5 by 5 and then make adjustments if I need to. Okay, good. Can I see the shape of the graph from this? Yep, okay, so let's go ahead and sketch it. I can see I have a point here at 0, 0. I'm going to use my table to find some other points. Oh, I'm at 500, so I'm going to go back to my table set, go back to 0. And at 0, I'm at 0. At 1, I'm at -3. And at 2, I'm at 0. And then at 3, I shoot up to 15. Okay, so this is going to be my curve. And then I'm also going to go back down, and I can see at -1, I'm at +3. And then at -2, I'm at 0. So I'm going to connect these with a curve. And how do our sketches look? Pretty good? Okay, so now I have to state approximately the intervals on which f is increasing or decreasing. I'm going to go ahead and highlight the increasing intervals. Okay, so the first increasing interval, would you guys agree, is from here to here? Okay, and then my second increasing interval would be there. So my first interval goes all the way up to this point, and what is that point called? Yeah, the max, okay, that's the local maxima. This is going to go to the min. So what I'm going to do is I'm going to find my max and my min on my graphing calculator. In order to find them, you're going to go to second calc. And I'll find the maximum first. And then it's asking you left bound and right bound. So I'm going to go here. And then I'm going to go a couple to the left. I'm going to go a couple to the right. And then I'm going to try to get right on there. Okay, so for this, I really only need to know what my x value is. Okay, and my maximum is going to be -1.15, 3.08 if I'm rounding correctly. This is going to be part of your interval. And then I'm going to do something similar with the minimum. Okay, so with the minimum, I'm going to go to second calc. Does this seem familiar from what you did in Algebra 2?
Yeah.
Okay, so I'm going to go to the left of the minimum, to the right, and then try to get right on there. Okay, and then my minimum is 1.15, -3.08. And that's going to be part of my interval. Okay, so what we're going to do is we are going to list the increasing intervals, which are the two that I just highlighted. So where did this interval start on the x value? -infinity. Then it went up to what part on the x value? Yep, -1.15. And it goes all the way up to it, so we're going to include it. And my other interval would start at +1.15 and go all the way up to infinity. And how many places do I have a decreasing interval? Just one, right? So from my maximum to my minimum, which I just highlighted in a different color. Does anybody think they can tell me what the decreasing interval is? What do you guys think? where would this be on your x value? Yeah, negative 1.15. And then it would go up to, what is this x value? 1.15. Okay, if you guys want, you can also, if you are not sure if you're going to remember how to do that on your calculator, you can write down that you're using the trace calc function on your calculator to find the local max and min. So if you're looking back, you know that that's what we did, is we used the graphing calculator to find that, but you don't have to. Okay, now for example 4, I want you to go ahead and graph that on your graphing calculator. Okay, so for example 4, did you guys already graph your new equation? Okay, and how was the graph when you first did it? Yeah, you couldn't see it too well, could you? Okay, so then we spent yesterday trying to look at some better intervals, so that's what I'm going to do. So I'm going to, actually I'll show you how to do the zoom in feature. So if you go to zoom in, there should be a cursor that comes up. You can kind of see it blinking right here. And then I'm just going to move over to the middle so it'll kind of zoom in on that entire graph. So now I can go ahead and draw a more accurate sketch of that graph. And again, you can use your table. So your table is going to be 0, 0. And then you have 1, 0. And then you can kind of see, it kind of looks like part of a heart to me. Or like a hill. So it's going down. And really, if you wanted, I just went by ones, but you could make your scale bigger, and you could go by different decimals, so that you could see that picture a little bit better. So this says to find all the local maximum and minimum values. So we also have to find the value of x at which each occurs. So find the local maximum and minimum values and the value of x at which each occurs. And then it says state each answer correct to 2 decimal places. Does this graph have a local max, a local min, or both? Well, there has to be a max, right, if there's a curve in it.
Yes.
Okay, so there is going to be a maximum on this. Is there any minimum? Is there any dip in the graph? No. Okay, so you're only going to have a local max for this. Okay, so that's not always going to happen. I'm going to say this graph only has a local max. So other graphs can have more than one. This one just has one. So we're going to go ahead and find our maximum just like we did before on our other graph. So we're going to go to second calc. And you can look at the y values. Can you guys see when it's at its highest point here? See how I have 0.319 and then I'm going up to 3.323, 0.324, and then I go back down again? So I can make my bounds so that I have my left bound and then my right bound, and then I'll try to get to the highest point there. Okay, and then it's going to give me my maximum. So first we're just going to write our maximum how you probably have been used to writing it. Well, we're going to say that the x value is 0.75, and that's rounded to 2 decimal places. Your y value is 0.32, rounded to 2 decimal places. Now, which one is your max? Is it the x or is it the y? It's the y. Okay, so when you're writing your maximum, what you're going to say is the maximum is 0.32 when x equals 0.75. Okay, so this is a different way than you've probably written it before. The maximum is 0.32 when x is 0.75. So the reason why we want you to write it like that is so you acknowledge which part is the maximum and which part is the x value where it occurs. So the maximum is 0.32 when x is 0.75. When you were doing your intervals, for the last one, we found the maximum, which was at negative 1.15, 3.08. So it kind of looked like your max was at the 3, but really it's going a little bit above that, isn't it? Because the max was at 0.308. So your maximum value here is 3.08, but that's going to correspond to the x value, which is down here, and your x value is negative 1.15, correct? Isn't that where the negative 1.15 is? And then same thing here. So this one, again, this is where your max is, or your minimum is, negative 3.08, and then the value on x is going to be 1.15. So we were finding the intervals on which it was increasing. So if you look, I'm going to do some highlighting here. So on your x-axis, can you guys see that the increasing interval is going to be from negative infinity to negative 1.15? Okay, and then from here, it's going to be 1.15 to infinity. So that is the interval that we wrote. For the decreasing, that's going to start at negative 1.15, and that's going to go to positive 1.15. Maybe I'll use this one. Okay, so we're going to do something similar for part B. It says find the intervals on which the function is increasing and on which the function is decreasing. State each answer correct to 2 decimal places. What I'm going to do is I'm going to draw another sketch of the graph right here. Okay, so this is what our graph looks like, right? Where does the graph start on your x-axis? At 0. And then where does it go to on the x-axis? It goes to 1. I have to find the interval on which it's increasing, which it's going to keep increasing until it gets to what? Until it gets to the maximum, right? And then it's going to start decreasing from the maximum all the way to 1. So what I have to do is find that maximum, which we already did. So the maximum value corresponding to the x-axis was what? What was our x value for the max? 0.75. Okay, so my first one is going to be the increasing interval. So that's going to start at what? It's going to start at 0. And then what's it going to go up to? 0.75. Good. Do you guys think you could write the decreasing interval for me?
Yeah, I think.
Okay, so where on the x does it start decreasing? 0.75. Can you guys see that? What I highlighted in blue, see how it starts decreasing at the 0.75? And then it's going to keep decreasing until it gets to what number? 1. And then it stops. Okay, so that would be your increasing interval and then your decreasing interval. Do you guys have questions for me on that? Alright, okay, let's try example 5. So between 0 degrees Celsius and 30 degrees Celsius, the volume V, which is going to come in handy, in cubic centimeters of 1 kilogram of water at a temperature T is given by the formula V equals, and then we have this whole function for V. We have to find the temperature at which the volume of 1 kilogram of water is a minimum. So find the temperature at which the volume is a minimum. So how can we do that? How can we find the minimum? What have we been doing all day? Graphing. Okay, so we're going to graph the function and then we're going to find the minimum value. And the minimum value, is that going to be your x or your y? The actual minimum, is that the x or the y value? That's the y value. Okay? So we're going to graph on a graphing calculator and we're going to find the appropriate window. Your temperature here is your input. So you can think of that like your x value. Okay? The volume is your output. You can think of that like your y value. Okay, and if you want just more explicit directions, you are going to graph on a graphing calculator and find the appropriate window. Usually the hardest part of that is finding the appropriate window. So we're going to go ahead and put our function in our calculator. So if you haven't done that, go ahead and do so. And t is our x value, so you can use the t. Okay, so I'll go ahead and graph it with the window I already have right now. Is that a good window? No. Sometimes there is a function on your calculator that can help you narrow down what the window is. Do you guys know what that special feature is?
Zoom for
Yeah, have you guys used Zoom Fit before? Now, sometimes it's not perfect, so let's try it out this time. So if I go to Zoom Fit, so I go to Zoom and then I select Zoom Fit. Okay, I can see part of the graph, but can I see my minimum or my maximum? No. So let's look at the window that Zoom Fit gave us. So let's go to window. Okay, so it gave me my x, it says negative 0.6 to x max is 1. So maybe instead, should we put our x max out to something else? What do you guys want to try? Okay. We'll try 5. And then my y min is close to what number? 1,000. Am I going to have to go higher or lower to see where that curve is based on the graph that you have? I'm going to have to go lower. Okay, so what should we try? That's a lot lower. You mean 950? Okay. Yeah, 950 or 900. Okay, and then maybe I would do this at 1,000 because the other part is too messy for me. Okay, let's graph. Let's see what we get. Okay, so for that, it looks like a straight line, right? Okay, so let's go back to our window. Let's try it again. Okay, so now I'm closer. So once I adjusted my window, I went to Zoom Fit again. Can I see this? Can I see that where the minimum is? Yeah, I can. Okay, if you wanted to keep going lower, you can, but let's look and see what window it gave us. So the X's were fine, and then for this, the 900 was just too big. That's how small the minimum was. Okay, so that's why you aren't able to see the curve as well. So now what we're going to do is we're going to go to second, and we're going to go to trace, and then we're going to find the minimum. So this one's a little bit trickier because you have all of this in the way. Really, you could try it, but I think I'm going to set up my window so that my min is going to, let's try 990. Okay, so that's still not as good. Alright, I'll try 998. Okay, I'll try 999. Okay, so it looks like that's going to be a little bit better to find out what my minimum is. And you can look here and you can see if the points keep decreasing. And see how it's like 0.750, now 0.74, 0.746, 0.745. It's going to keep decreasing. So I might do my left bound here, and then my right bound here, and then try to find that spot in the middle. Okay, and then did you guys get your minimum? Do you guys have the same thing as I do, or do you have something close for your X value?
3.966.
Okay, yeah, 3.9665.
Yeah.
Is that what most of you guys have?
Yeah.
Did you guys do the same window thing that I did, or did you keep it how it was before?
I just kept it, yes.
Okay. I'm gonna try that too. So I just did my Zoom fit one more time. And I'm gonna go to second trace, and I'm gonna go to my minimum. And again, I'm gonna use my Y values to help me figure out where that minimum is. So my left bound, your bounds are just telling you what areas are you gonna look between. And those are starting to get higher. Okay, good. So did you guys get 3.9665527? And then 99.744. Okay, so the temperature is your X value. Therefore, the minimum is going to occur when the temperature is approximately 3.97 degrees Celsius. Okay, so because you are finding the temperature is your X value. Okay, so the minimum occurs when the temperature is approximately 3.97 degrees Celsius. So it's not asking for the minimum, but it's asking for when the minimum occurs. If it asks you for the minimum, then that would be the volume, and that would be the 999.74, your volume, measured in cubic centimeters. Okay, so the minimum occurs when the temperature is approximately 3.97 degrees Celsius. So that would be your solution. Okay. All right, and here is your homework.